Okay, let's continue. Now, so you see this impulsive force happens everywhere. Okay, so for example, 跳高, a high jumper. Okay, when high jumper falls on a mattress, okay, you have very thick mattress because the thick soft mattress, it lengthens the time of impact. Okay, so when you fall on it, it won't hurt that much. The impulsive force acting on the high jumper is reduced, and he is less likely to suffer any injury. Okay, so that is one of the what application. And another 跳远, long jumper. So long jumper, you have this very long line of sand, right? Loose sand. So we use loose sand. Okay, so long jumper, he lands on this pit filled with loose sand. Now the loose sand lengthens the time of impact and reduces the impulsive force. Okay, so and also if you're catching like catching the baseball player, he wears a glove, right? The glove, a thick glove made of very soft material. Again, it also lengthens the time of impact and reduces the impulsive force acting on his palm. Okay, so usually you see this motion. Even though I've never played the baseball, right? So you see this when you catch the baseball, right? You have to move your hand backward a little bit. You have to tends to follow the motion of the incoming ball. Okay, so you can reduce the force coming in, hitting your hand. Okay, so this one you see the same thing happen to all the aerobatic guy, the gymnasts, the aerobatic sports. Okay, or even in the movies you see that. Okay, in all the actions movies, you see people jumping from the high building down the street, right? So they do what they do when they reach the ground, they don't keep their legs straight, they don't keep their legs straight because it will break their leg. Okay, so let's say you jump. Okay, let me, ground, this is a building. Okay, you're jumping out of the window, let's say that. Okay, when you reach the ground, you cannot keep your leg straight. You will keep your leg straight, and then the impulsive force is great enough to break your leg. Okay, so what you do is you observe that most of the people, when they fall, right, they will bend their knees. They bend their knees, they do it like this. See, they bend their knees. So why they bend their knees? They bend their knees is because they want to increase the time of impact. They want to lengthen the time of impact so that the impulsive force acting on their feet from the ground like this is minimized to the as much as possible. Okay, so know that impulsive force is always acting from the direction of the surface. Okay, let's say this is a wall, right? This is a wall, and then you have a ball moving towards it, and then the ball moving towards it, when it hits the wall, how do we label impulsive force? We don't label like this. No, not this one. It has to be coming out of the surface of the wall. Okay, out of the surface of the wall. So if it question asks you to label impulsive force, then you label like this. Force like this. Okay, even though it is the ball hit the wall. Okay, the wall just stand there, it did nothing, right? But you still have to label the force coming out from the wall as if the wall is acting the force on the ball. Okay, so same, when the ball strikes the wall is transferring a force onto the wall, but at the same time the wall is also reflecting back the force onto the ball. All right, so understand this sentence. Okay, understand this sentence. Right? Is later we'll come to a chapter where you learn about Newton's third law of Newton's third law of motion, action and reaction. I don't know, maybe you have learned about it. Okay. So now back to this one. Okay, so you see, you can put the impulsive force as in a useful condition, or you can put it you can just play around with the time of impact. For example, what application requires a high impulsive force? It can be pestle and mortar. You know the pestle and mortar. Pestle and mortar, the one that you see your mother used to crush the garlic and stuff. Used to crush the garlic and used to pound the spices like chili, onion, and garlic. Okay, that one is made of very hard uh, type of stone, right? It's made of stone. Okay, let me show you the, yeah, 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 this one also made of stone, made of a type of stone. Okay, so it's used to crush all the spices. So the impact time between the pestle and mortar is very short because they're hard and rigid surface. Same with the blacksmith. Blacksmith, what do you call blacksmith in Chinese? The 铁匠啊，铁匠. So the one that you work in the in the industry where they use the heavy hammer, right? They use the heavy hammer and the anvil to forge metals. Forge metals. What does it mean by forge metals? Meaning that to shape it, to shape metals. Because metal is very hard, right? So to shape the hard surface, first you need to heat it. You need to heat it until it becomes glowing red. You see this glowing red and orange color, right? So and then you hammer it on one side. Hammer it and then you bend it, right? So and then you left it to cool down and it will be, the shape will be like, you will get your desired shape. Okay, the anvil is just a flat with a flat surface where, yeah, this one, a flat surface where you hammer on it up. Okay, hammer and, yeah, something like this. Okay, also made of very hard materials to shorten the time of impact. So all these hard surface okay, they shorten the time of impact and increase the impulsive force. This is a type of situation where we want great impulsive force. Same as golf club. Golf club has very hard hitting surface. Okay, no, golf club can be very dangerous. I don't know if you have ever played golf, and I've never played golf. I've never had a chance to play golf. Okay, the golf club is very hard and it's very dangerous. If in case you mishit somebody, it will cause a very severe injury, right? So okay, enough of this, all these things, common sense, okay? Common sense. Now you know the point is you understand impulsive force, right? So impulsive force is depends on the time of impact, and the longer it is, the shorter it is. The longer it is, the smaller the impulsive force, and the shorter it is, the greater the impulsive force. Okay, done with that. Now I'm going to show you two examples, and then can not this one. Yes, okay, this one. Right, my pen is okay now. Okay, now look at the example here. A boy hits a 0.5 kg ball and send it moving in the opposite direction, meaning upward. So figure shows the magnitude of its velocity before and after being hit. The time of contact between the hand and the ball is 0.05. So usually the time of contact is given. Time is 0.05. So this one, the contact happens at very fast, 0.05. So calculate A, the impulse applied to the ball. A. Calculate the impulse applied to the ball. How do we calculate the impulse? Now we know that what is the formula for impulse? The symbol for impulse is I equals to Ft. This is impulse. But since in this case, F is not given, there's no force given here. So we use another formula. Impulse equals to mv minus mu. Remember, I said about impulse also equals to change of momentum. So change of momentum, in this case, what is the change of momentum of the ball here? Of this ball. Okay, so initial velocity is 15 and final velocity is 20. So you just calculate the change in momentum. Okay, so mv, now this one is very important here, direction. Okay, initial velocity is acting upward or downward. It's acting downward, right? This one, the first one, is coming down. Initially, it's coming down, and after the boy hits it, now it's going up in a different direction. So when you're dealing with directions, most of the time, I would encourage you to take the initial direction as positive. Okay, I would encourage you to take the initial direction as positive, meaning the initial direction is downward. So taking the direction to the downward as positive. Okay, downward as positive and upward as negative. Now, mv, mass is 0.5. Now, the final velocity of the ball is 20, right? So 20, but it is acting upward, so it's negative 20. Negative 20 minus 0.5. And the initial velocity is 15, and it is positive because it's acting downward. All right, so if you do the math here, I don't have to show you the steps to do the math. You times this one, times this one. Okay, after that you will get negative 17.5 ns. This is your answer. Okay, so you notice that there is a negative there, right? Change of momentum. So impulse is equals to negative. So impulse also is a vector quantity, meaning that impulse has direction. Okay, so negative impulse means the momentum change. Okay, there's a momentum change of increased momentum. Okay, now let's look at B. The impulsive force exerted on the ball by the hand. Okay, so when the ball hits the ball, there's an impulsive force. Ball acting, there's an impulsive force transferred from the ball to the hand. And at the same time, the hand also exerts an impulsive force on the ball. So it's both directions. It's both directions. So later you understand more about it when you learn about the Newton's third law. All right. So impulsive force exerted on the ball to use, there's only one formula. F equals to mv minus mu divided by t. So since on top one, this one is impulse, you can just take minus 17.5. It's the same thing as this one. Divided by 0.05 seconds. So you will get the answer as negative 350. Negative 350 Newton. Now, I want to talk about this one. I want to highlight about this one. You see the impulsive force answer is negative 350, right? Why is there a negative for impulsive force? Okay, so remember just now I said impulsive force always acting, when you label impulsive force, you always draw the arrow coming out of the surface. Okay, like this one, you look at the bottom left here, I draw it here. A ball is moving towards the wall. What is the direction of motion of the ball? It's to the right. Okay, after it hits the wall, and then there is an impulsive force. How do I label the impulsive force? This arrow here, this one, the one I black. Okay, so notice the impulsive force is always coming out of the surface. So it is always opposite to the direction of motion of the object, right? So it is opposite to the direction of motion. So meaning you will always get a negative for impulsive force. Clear? You will always get a negative value for impulsive force because the impulsive force will be acting opposite to the direction of motion. Okay, so in this case above here, the boy hitting the basketball. Okay, let me erase this a little bit. Okay, the boy hitting the basketball. Basketball initial motion is coming down. So when the boy, this is his hand. Oh yeah, how to draw a hand? I don't know how to draw a hand. Something like this lah. Okay, impulsive force is acting like this. Okay, so it's opposite to the direction of motion, and which is why you get a negative. Yeah, now done with this one. Look at the second example. You want a screenshot or not? If you want a screenshot, then you take it now because I want to scroll it down. Okay, last example, then you try out the exercises, right? Now, figure shows a boy kicking a football and a rock, right? So A, from figure 2.1, when the boy kicks the 1.2 kg football, it moves from rest to 15 in 0.1 second. Calculate the impulsive force exerted on the ball. Okay, same, we use F equals to, okay, let me take, so A here, F equals to mv minus mu divided by time, right? So the mass of the ball, 1.2 kg, the final velocity of the ball. Now, in this case, before the boy kicks the ball, the velocity of the ball is 0. So u equals to 0. After he kicks the ball, v equals to 15. Okay, so notice in this entire process, the ball is moving at the same direction, which is to the right. Okay, so we don't have to worry about the sign anymore because the velocity is acting at the same direction. Okay, so v here 1.2 is m and v is 15 minus 1.2, u is 0 divided by time, so 0.1 second. Okay, so you can easily get this 180 Newton. 180 Newton. Okay, so in this case, the impulsive force is positive. Okay, again, how do you label impulsive force? It is acting to the right, positive. Okay, acting to the right. So it is not opposite to the initial motion of this in this case because initial motion is not moving. Initial is just at rest, right? Okay, now B, the boy then kicks a rock of the same mass and it moves from rest to 15. However, due to the rigidity of the rock, the time which the foot acts on the rock is only 0.0. Now, this time is different, 0.01. What is the impulsive force exerted on the rock? Same way to calculate it. B, F equals to mv minus mu, or T equals to, okay, so 1.2, and the velocity, final velocity, okay, it's the same thing. Just the time is different, 0.01. Okay, so if you calculate this one, you will get 1800 Newton. Okay, C, from the answers in A and B, what is the relationship between the time of impact and the impulsive force? Now, this is obvious. Just look at the time and the impulsive force. You see both cases, he kicks the football and the rock. It's the same speed, same mass, just that the time of impact is different. So the first case, the time of impact is longer than the second one, right? This is 0.15 and this is 0.01. So just a tiny bit of difference here. You see the force. One is 180 and the other one is 1,800. So meaning that this time shorter time of impact and higher impulsive force. Longer time of impact, lower impulsive force. So how do you say the answer here? The relationship is just impulsive force is inversely proportional to the time of impact. Okay, so if you want to put in formula, is F like this. Okay, so we are going to stop temporarily until here. I'm actually thinking to 我还在想着要不要继续教下去，可是我又想到下一个 part 那边是会比较满，所以我觉得剩下的1个钟我们来不及。So and also if I stop at halfway, which is also possible, but if I stop at halfway, then next week then I have to revise again. Okay, so it's better to I'll give you the exercise first. Now give you the exercise, then you try out for this one, impulsive force. I have like 30 something questions for this one. Okay, so you try out this one, and then if you have any questions, then we take this as a Q&A session. Okay, if you have any question, please straight away just ask. Okay, so just make use of the time lah. Make use of the time because we are only once per week, and just take this as a Q&A session. So if you have finished all the exercise, later I'll send you the exercise. If you finish it, then you let me know lah. I'll see whether I want to continue or not if we have enough time. All right. But right now, I'm just going to send you the exercise. Though, so from now on, I'm trying to do all the exercise myself. So I will provide you with an extra solution sheet, so you can look at it. So every time that you feel don't understand, then you can just look at my solution. If you still don't understand, then you can ask me here. Okay. So the solution sheet is of course just to help you, because there are some questions that a few words might explain might be enough to explain to you lah. Okay. No need to like go through it every questions. Yeah. Okay. I'm going to send exercise. Give me 2 minutes like this lah. So also you can take a rest, drink water, or go to the bathroom or anything lah. Then I'll come back to you in 2 to 3 minutes. OK，如果你看the first worksheet 啊，2.6 analyzing impulse and impulsive force 啊，我只是 send 给你两个吧。第一个，你看第一个2.6，然后它有22题的那个，你看第18题的，第18题是 ticket timer 来的，我还没有教你们那一个 ticket timer，所以你们可以 skip 那个，或者你也是可以 try，如果你的学校已经教了啦。Okay, so just to let you know that question 18 is the one that I haven't taught you yet. 因为之前我也是有想要知道你们学校几时教你们那个 ticket timer，可是我有问谁啊，Edison 有跟我讲还没有教 ticket timer 是，so you can skip that one. Okay, so we have 40 minutes, and please take this time. If you have questions, message me privately, or you can just ask it here. Okay, just don't keep it to yourself. Okay, so I'll try my best to explain to you, and if it's still confusing, still you cannot understand, then you can let me know. You can say, oh, can you explain in other ways? Then of course I'll try to explain in other ways. Okay, okay, so I'm going to, yeah, nothing much lah, just let me know. Okay, yeah, the meeting left 4 minutes. So later after 4 minutes, then I'll post the link again. Okay, no need to quit lah. Just leave it like this. Then after 4 minutes, then I'll post the link again.